Now can we have the yellow team, please?
Show the microphone.
Yeah, why not? Where is
I
it?
think I'll be right.
Where is it? We good to see? Okay. Hi everyone, we're the Yellow team and we're here to tell you about our project, the MICROGRO, which aims to provide rapid diagnostics in pathogenic diseases on the go.
So, antibiotic resistance is rapidly increasing as antibiotics are overused and misused across the world. According to the World Health Organization, already in the EU, 5 to 12% of hospital patients acquire an infection during their stay. Of this, 25,000 die yearly from resistant strains that they've acquired. This costs the EU more than 1.5 billion a year. And as this nice sensationalist statistic shows, it's suggested that by 2050, one person could die every 3 seconds from antibiotic resistance, with a potential economic loss of $100 trillion. There's an obvious need for rapid and accurate detection to assure of disease, to ensure that targeted antibiotics can be used in the correct quantities to reduce the risk of antibiotic resistance developing. And this has been supported by the 2014 O'Neill report, which suggested up to $1 billion stimulus for companies trying to tackle this problem.
So this is our team. I'm Sophie, I'm a managing director and I originally came up with the concept for the project.
I'm Tom, the Chief Scientific Officer, and I use my specialisms in engineering and biotechnology to develop new products.
I'm Phil, I'm responsible for marketing and commercialization. I have a master's in business from UC Berkeley and I've worked for Illumina and Monsanto.
I'm Jim Horn, I'm the operations manager, so I have a PhD in biotechnology and I also have experience in computer science.
And I'm Anna, I'm responsible for finance, so I come from a finance background.
So what are the conventional detection methods for identifying bacteria or pathogens? So there's common biochemical assays like gram staining. These are fairly low cost and easy to carry out, but lack the accuracy that we need. So proteomics-based methods are also accurate and high throughput, but are very costly to maintain and carry out. So sequencing methods and genetic fingerprinting techniques are also fairly accurate, but have a low throughput. And then finally, microarrays are a low cost and easy to use method. However, they lack the ability to identify a range of pathogens in a given sample. So what is our product and how does it address these shortcomings? So MICROGRO is a portable rapid detection device capable of diagnosing the presence of a range of pathogens in a given sample. So it has an innovative portable design, easy to read display and Wi-Fi connectivity, so it can be used in almost any environment to provide point-of-care diagnosis with specific medicines. So the product builds on existing microarray technology. However, we've adapted it for use in a clinical setting. So we use customizable, reusable chips combined with our enhanced detection system, which allow it to accurately identify a range of pathogens in a given sample. So furthermore, there's no laborious sample prep, which allows us to identify a pathogen in a matter of minutes, saving both time and resources.
So as mentioned, there are many different methods to use for this kind of industry, and we have a number of competitors already on the market offering a variety of different products. However, we feel that the market is far from saturated, and as you've mentioned, our disruptive technology could fit into this and hopefully propel innovation further in it. Our competitors include companies such as Vitek, MS, RiboPrinter, DiverseLab, and Alia. They all offer the previous techniques that we mentioned. So the global market for molecular diagnostic tools such as ours is valued at 5.3 billion. And The majority of this comes from the American market, with 10% coming from the EU, and Britain fitting in with that, with a market size of about 130 million. As a relatively young startup company, we're hoping to capture just 7% of this, which, if my maths is correct, is somewhere around 9 million. And just do that within the first few years of our company in operation before expanding into the US to tap into the massive amount of money available there. As part of our market research, we surveyed hospitals across the country about their current analysis techniques and what they hope to see in the future. We had an overwhelming message saying that they wanted portability, rapid responses, and low cost, which we've worked our best to optimize. And mentioning hospitals, our target market is private hospitals and hopefully the NHS eventually, rather than the end service consumer. So we're going to be targeting these through conventions and symposiums where we can explain the benefit of our product, along with free loans of our kits to these establishments so they can test it out for themselves. There are 136 NHS hospitals in the UK and about half as many private hospitals, so we're not running out of customers anytime soon.
So from our base in Leeds, we started an initial R&D where we developed a hardware prototype as well as software and algorithms to interface with this hardware. From this R&D, we've had 2 patents pending, one for the sample preparation methodologies and another for the data analysis algorithm. In year 3, we produced a scale prototype, and we used that in a proof of concept pilot clinical trial in the Leeds Teaching Hospitals Trust, where we analysed samples from 30 patients. This trial was a great success. The device performed as expected, and it gave identical results to those from a professional clinical microbiologist. So this chart here just gives you an idea of the journey we've been on so far and where we're hoping to go in the future. So in year 1, we secured a £100,000 grant from the UK Fleming Fund, which we matched with a bank loan. We used this for our initial R&D and also to apply for our patents in the UK and EU, as well as trademarking across both these markets. In year 3, we secured a £200,000 grant from Innovate UK, which we used to fund the production of a scale prototype and for the first pilot trial. What we're looking for now is further investment to fund a larger trial in order to fund our initial manufacturing costs. With this larger trial, we'll gather data which will allow us to apply for CE marking to sell our product across the UK and EU markets. So we're going to manufacture our product in China in order to keep costs low and then ship it to the UK. But we will also maintain a base in Leeds where it will allow us to have point of contact with our actual trial to provide technical support, and also for the application process, so that we'll have somewhere where we can refine our product and respond quickly to any questions or problems from the MHRA.
So how this looks in terms of our finances. So we have used our initial funding to develop the prototype and do the proof of concept studies. Now we're asking for funding to do our pivotal trials, set up our production line, and grant MHRA and the CE certification. So we are planning to do this in 2 years, so that's quite a lot to do in 2 years, but we are willing to start to sell our product in year 6. And our current estimates would be that we would sell the core device, which would be about £1,000 per device, and we would sell reusable chips, which would be about £50 for a chip, which would be reusable for 5 times, which would cost about £10 per a detection system that works in minutes. So I think that would be a very good cost effective for healthcare professionals. And we expect our sales to grow, as the graph suggests, and we are expecting to reach gross profit of 10 million in year 9, so that would be about 7% of UK market.
So to summarise what we've done so far, we're currently entering our 4th year as a company. We've done some preliminary pilot trials where we have had a lot of success and have gained significant feedback, mostly positive, which is good. So far, yeah, we've conducted some photography, but we think that our company can do so much more, and that is where our future prospects comes in. We plan to expand further once we obtain the UK market as much as we possibly can. There's potential to expand to the EU and North America, which currently dominates 80% of the entire global market. And there's also, due to the very nature of the technology that we use, its portability and its ability to detect away from a large system, can expand it into different industries such as agriculture and ecology, where antimicrobial resistance is, like we heard previously, on the rise and could do with more specific detection and prevention strategies. As you saw in our previous graph, it ended at year 10. At year 10, we're going to reevaluate our company's finances and see how we are. And if it's going well, we're going to sell to a much bigger company with much more capability of handling the kind of money that we'll be making. So that's it from us. So hopefully you guys can see the potential in our product and where it can go. So we are my bad. So based on our calculations, MICROGRO has the potential to develop into a multi-million-pound company. That is why we're asking you for a £1 million investment for 20% of our company shares with 20% returns for profits per annum. That will probably get you about 400% increase on what you originally paid in. So, according to our calculations. MICROGRO has identified a need for rapid disease diagnostics that need to be portable and accessible anywhere. And there has been a global call for that, and it's up to you to answer it. The end.
Thank you.
It's a fantastic idea. There really is a need for diagnostics. What's your speed of detection?
15 minutes, half an hour.
It's too long. You need it to be 5 minutes. I'll tell you for why. You're missing your target market, which is GP surgeries. I think 61% of all GPs have said they would like to use point-of-care diagnostics. But a GP appointment is 10 minutes max.
You could argue that they sit in the waiting room for a good half an hour before the
But
appointment.
nobody's testing them, are they?
Yeah.
And the real point here is for reducing antimicrobial resistance is to prevent people getting antibiotics that don't need it, so you need virus versus bacteria. That should be your first test. And if you could crack that, you're onto a winner.
We're hoping to tackle both viruses, and the different chips are very customizable.
That's brilliant, and I think getting that into a hospital setting would be wonderful. Can it work with all different types of sample?
Yes, we believe so. So far, anything that has DNA that can be broken down for our samples to test, then yes.
Okay, thank you. Thanks for explaining the market. Obviously, a huge unmet need here. Without addressing the science, I'm a business person, you're asking me to put money into your company. And be brief, please. What do you think the number one business issue is with respect to this market and this opportunity?
I think the biggest problem could be creating a demarcation line between ourselves and other companies to make sure that we actually stand out in quite a large sea of techniques that are all trying to vie for consumer attention.
I think that's a good answer, and I'm glad you've said it, because you very eloquently demonstrated the size of the prize here. It's enormous. You described what looked to me a generic kind of chip-on-chip technology behind it. There are hundreds of companies going for this. The competition here is going to be white hot, so you need to be able to be very confident that you're going to be a winner here for this automation. Thank you for that. Just a couple of very quick questions. I've done to other people, so I'm going to do it to you. What do you mean? What does 20% return of profits, return per annum? What does that mean? Does that mean you're giving investors 20% of your profits every year?
Yes.
Okay. When are you doing that? Is that a smart move? A lot of companies should be reinvesting their profits in the company. You're giving it to me as a dividend. I'm not sure I like that, actually, even though I like money. Maybe you should be building value in your company for me instead.
Well, we're still keeping 80%.
For now. There's another plan to get some more investors in 2 years' time as well, but it's...
This is a risky business to go into, so
Okay.
we're trying to make it as attractive.
I like your answer there, build equity rather than returning early. Last thing, like the chart on finances, the hockey stick, that's good for me. The relationship between gross profit and net profit doesn't work that way. You're going to be making a lot less net profit than gross profit. Every business is.
Yeah, I like the concept. It just was not quite enough information for me to make a good decision just on the business plan. So, are you going to get it into markets yourself first and then be looking for someone to buy it from you? I mean, I know you did cover it, but it wasn't very clearly covered, so...
So we're hoping to sell this product ourselves to the hospitals to begin with. And the exit strategy is more so a 10 to 15-year plan based on how we're developing, because a lot of upstart companies tend not to exist by themselves for very long before you get gobbled up by a bigger corporation. And it's better to factor that in early to expect it to come.
Good. Did you talk to anyone about this?
We got in contact with someone at Ferrer, actually.
Okay, good.
There's a company at Ferrer called Origin, which are trying to do a similar thing, but more sequencing based.
Yeah.
And
So potential competitors.
sort of, but not really.
They're looking at
they're more
food.
food.
Yeah.
So, which we have the potential to expand into. So potential competitors, but it was more of a concept. Could our idea actually work?
And what did they say?
They haven't emailed back. They haven't emailed back yet.
Good. It's annoying when people don't reply. All right. Okay. Any other questions? That's good. All right. Thanks, guys.